One.
All right, AP Stats people, let's make this one the last one. 33. A mathematics competition uses the following procedure to discourage students from guessing on multiple choice questions. For each correct response, the score is 7 points. For each question left unanswered, the score is 2. For each incorrect response, the score is 0. There are 5 choices for each question. What is the minimum number of choices that the student must eliminate before it's advantageous to guess amongst the rest? So I started by thinking if you're guessing randomly, there's 1 out of 5 that are actually correct. So you'd get 7 points for that. And then 4 out of those 5 that you get 0 points. With an expected value. So if you're just doing that, you should be expecting to get about 1.167 points. Now, that means at that point, it would actually be better to leave it blank, because if you did this method, guessed with out of 5 choices, you would have an expected value of 1.167. Next, if you actually were able to eliminate one of them and bring it down to 4, so 1 out of 4 are correct, and then that would mean 3 out of 4 are wrong. But still, that means your expected value, if you tried this many times, you'd be netting 7 over 4, which is still 1.75. Anyways, it's still more advantageous to just guess, because you'd be getting 2 points if you just left them all blank. So keep this pattern going, and you can see which one you should guess. How many until it's beneficial? How many would you eliminate until it's beneficial to start guessing? Because if you just eliminate none or eliminate one, it's still more advantageous to leave it blank. 34. The probability that a new microwave oven will stop working in less than 2 years is 0.05. So stop working, 0.05. The probability that a new microwave oven is damaged during delivery and stops working, so I'll make this one damaged and stop working, is 0.04. I probably didn't need to do that arrow. The probability that a new microwave oven is damaged during delivery is 10%. So given that a new microwave oven is damaged, during delivery, what is probability that it stops working less than 2 years? So probability that it stops working, given that it's damaged. Remember, this is a conditional probability. You should be thinking both over given. So both is 0.04 over what was given, as that it was damaged, 0.10. That should make that pretty clear. I probably helped that one out a little more than I had to. Perchlorate is a chemical used in rocket fuel. People who live near a former rocket testing site are concerned that the perchlorate is present in unsafe amounts in their drinking water. Drinking water is considered safe when the average level of perchlorate is 24.5 parts per million. So that's safe. Parts per billion. Random sample of 28 water sources in this area produces a mean chlorate that's a sample of 25.3, which is above the safe level. So that means, well, this is probably our null. So when we're setting up there's a couple things we can eliminate here. First, the alternate and the null both have to be about the parameter. So these that start with the sample, you can eliminate. It doesn't ask if it changed, so we shouldn't be using this. And there's actually evidence saying that there's evidence that it may have increased. So you'd be testing the alternate hypothesis that this has actually increased because our sample is above what our hypothesis was. 36, the computer output. Okay, which of the following statements is a correct interpretation of 19 in the output? You look here, 19. Just identify that 19 as the slope. Tell me which of these is a correct interpretation of that then. There were 5,317 previously owned homes sold in a Western city in the year 2000. The distribution of the sales prices was strongly right skewed with a mean of that and a standard deviation of 37,881. If all possible, simple random samples, sample size 100 should tell you if it's or what the shape is going to be for the distributions of sample means. So even if it started right skewed, if you have a large enough sample, the distribution of sample means is going to be approximately normal. And then that means we'll be using population standard deviation over square root n. You should be able to then figure out which one you'd be using there. A physician believes that the exercise habits of East Coast adults are different than the exercise habits of West Coast adults. Exercise of East Coast and the exercise of West Coast. Well, kind of gave that away. Pretty much always when you have two samples or two proportions, the null is always going to be that they're equal to. Read it and you should be able to do that one. 39 for a roll of a fair die, each of the outcomes 1, 2, 3, 4, 5, 6 is equally likely. A red die and a green die are rolled simultaneously. So just play around with some numbers. Let's say the red one was a 4 and the green one was a 2. We could get and subtract them out. Outcome 2. However, if the red one's like lower, switch them up. If the red one rolled a 2 and the green one rolled like a 5, well, then you'd have some negative numbers. So you really want to look and eliminate some of these that don't even have negative outcomes. And then think, are all of them going to be equally likely, or are the positives and negatives going to balance out on each side with 0 right about the same? Determine between those two. And number 40, last one, the probability of winning a certain game is 50%. If at least 70% of the games in the if at least 70% of the games in a series of n games are won, the player wins a prize. So they need to win 70% of the trials in order to get that prize. So it's essentially asking to win 70% in a sample size 10 would be 7 out of 10. 70% out of sample size 20 would be 14 out of 20, or 70% out of 100 would be 70 out of the 100. It's asking what is the most likely to occur when your sample size is 10, when your sample size is 20, or sample size 100. Generally speaking, you get the best data when you have a large sample size. So large sample sizes should balance out to right around the 50%. So if you have a large sample size, it might not be weird to get 51% or 52% or 48%, but it would be really strange to be getting 70 out of 100. It's not impossible, but it's really unlikely. But with small sample sizes, really anything can happen. So use your judgment on that one. Anyways, good luck. We'll be talking about this in class shortly.